All right, good morning, Giants. I hope you're having a good day. Today we are going to talk about some story problems. So we've already learned our three different methods for how we can deal with these. SOHCAHTOA, law of sines, or law of cosines. And today we are going to talk about how we can solve these story problems using one of those methods. So remember, in order to use SOHCAHTOA, we have to have a right triangle. SOHCAHTOA is probably the easiest one, but you can only use it if you have a right triangle. Okay. Law of sines, you could use this on even on right triangles. It's probably next easiest. In order to use law of sines, you have to have a partner. Now, what I mean when I say a partner or a pair is you have to have not only an angle, but also the side across from that angle. Okay? You have to have a match. And then finally, law of cosines we can use as long as we have three pieces of information. Okay? So two sides in an angle or three sides. Okay? So example 1 here says three little kids are playing catch with some baseballs. So Allison throws the ball 20 feet to Ben. So Allison is going to throw it 20 feet to Ben. Turn 35 degrees and throw it 25 feet to Caleb. Now our question is, how far is Caleb away from Ben? And we want to know what that distance is. So x, that is a missing side. Okay, so x squared, in order to find, sorry, I should slow down. Before I write that, let's think about this. Is this a right triangle? No. We don't know for sure what C or B is, but we know it's not a right triangle, or we can't prove it's a right triangle yet. Okay? The next thing we want to look at is what about, can we use law of sines? So in order to do that, we have to have a matched pair. And we have 25 feet pairs with B, which we don't know. 20 feet pairs with C, which we don't know. 35 degrees pairs with X, which we don't know. So we cannot use law of sines. We'll have to use law of cosines. We are solving for a missing side. So use yesterday's notes formula for law of cosines, finding a side. So x squared equals, now it's the two sides that aren't making up that squared. So 25 squared plus 20 squared minus 2 times those, so 25 times 20 times the cosine of our angle, which is 35. Okay, so we type that in the calculator, and whenever we get our answer, we're not quite done though. So 25 squared plus 20 squared minus 2 times 25 times 20 times the cosine of 35. We hit enter, 205. That's not our answer though. We still need to take the square root of whatever our answer is. So second square root, second answer, and we hit enter, and we get a distance, if we go to the nearest tenth, of 14.3 feet. That would be our answer. All right, number 2 here says an 80-foot tall tree is casting a shadow of 122 feet. So 80 feet tall, we know height is up and down. Trees are almost always straight up and down. Cast a shadow will be along the ground, 122 feet. We have our right angle, and the angle of elevation is above horizontal. Okay, so that is going to be what we are trying to solve. Now on this one, we do have a right triangle, or right angle, so we can use SOHCAHTOA to solve this. Okay, so if we think about it, 80 feet is the opposite. 122 is the adjacent, so we can use tangent, TOA. So we will do the tangent of x equals O over A, so 80 over 122. And to solve this, we got to do the inverse tan of those others, 80 over 122. That will tell us what x is, and we are going to round to the nearest whole number. So inverse tan, to get this, hit second tan, 80 divided by 122, close your parenthesis, hit enter, we'll get 33 degrees. Okay, number 3. This is probably the one that is most difficult of these 5. It's a little bit unique. We haven't done it. You're going to have to kind of do 2 different things. So it says 2 observers are on the ground and they see an airplane in the sky between them. So we have A, and over here we have B, and somewhere up here is an airplane. Okay. Now, observer A measures an angle of elevation of 27 degrees. So that goes right here, 27 degrees. Meanwhile, observer B measures an angle of 35 degrees. And it tells us that observers are standing 19 kilometers apart. Now here's where it gets a little bit interesting. Our goal is to find how high is the airplane off the ground. So the airplane right here, this is height, straight up and down. Now, since that's height, I can put a right angle in here because height is perpendicular to the ground. So it forms right angles, but that right angle is not part of the big triangle, which we will use at first. That big triangle, we can figure out what this missing angle is, but it's not going to be a right triangle. It's 27 and 35. If we add those together, then we'll get 62. We'll take that from 180, and we'll have 118. That goes right here, 118 degrees. Okay. Now, we want to solve for one of these missing sides. We can't use SOHCAHTOA because it's not a right triangle, but we do have a set. Not only do we have a 19, but we have a 118. Okay, so those ones match up. We can use the sine of 118 divided by 19 equals the sine of either 27 or 35. If I choose 27, then I'll put that over little a. That's what's missing from right here. Okay, so now we'll cross multiply sine of 118 times a, 19 times sine of 27. Then we'll divide by that sine of 118 to find what a is. So 19 times the sine of 27. Also remember, before we could do these, you should have checked, make sure your calculator's in degree mode. Mine already was, so I forgot to do it, but double check. So 19 times the sine of 27 divided by the sine of 118. All right. We hit enter, and we get 9.8 if we round to the nearest tenth. So in place of that a, I'll change that to 9.8 kilometers. Now here's where it gets a little bit more confusing. We're trying to find the height. So if I redraw a right triangle, and let's have this triangle be the one right here. If I grab that and brought it down here, we know that 9.8 goes right here. We know it's a right triangle. We know 35 is right here. And we know our end goal is to find the height. Whoa, hit that. So that x. So we can solve this using SOHCAHTOA. I know that this is our hypotenuse. This is our opposite. So if we use SOHCAHTOA, it will be sine. The sine of 35 divided by 1 equals O over h, x over 9.8. We'll cross multiply, and we'll get x equals just whatever 9.8 times sine is. So 9.8 times sine of 35. Close it and hit enter, and 5.6. Yep. And that would be kilometers. All right. two more. This next one here, it says a building is 205 feet tall. So buildings, unless maybe the Leaning Tower of Pisa, are going to be straight up and down. So that's 205 feet. It says the angle of elevation. So that's above horizontal. Angle of elevation is 57 degrees. We know how far a person is standing over there from the ground floor. So that'd be X right there. We know it's a right triangle. If it's a right triangle, let's do SOHCAHTOA. So all we have to do, label these adjacent, opposite, and now we can go. So O and A, tangent. So tangent of 57 equals O over A. So 205 over X. We cross multiply. We'll get 205 equals the tangent of 57 times X. We'll divide that by the tangent of 57. And that'll tell us what X is. So in order to do that, just pull up your calculator. 205 divided by the tangent of 57. And we get 133 feet. And we're done. Final one here. Bridge is supported by a triangular brace. Sides of the brace are 63 feet, 46 feet, and 40 feet. We're going to find the measure of the angle opposite the 46-foot side and round to the nearest degree. So, start, if we draw a triangle. So I keep hitting the arrow. Oops, 63 feet, 46 feet, and 40 feet. Now, opposite of that 46 feet is what we're trying to find. So if we go to 46 and go opposite, that's in this corner. Now, we can't show that this is a right triangle. We have no way to know that. We also don't know if that, so we can't use SOHCAHTOA. We also don't know what that missing spot is, any of these angles, so we can't use law of sines. So instead, we are going to have to use law of cosines. So cosine of A equals, it's always the two sides that we're not opposite of. So the 63 we squared plus 40 squared. Make sure to put this top part in parentheses and subtract the one that is opposite the angle we're finding. So the 46. All that's divided by, then it's the two that aren't beside it. So 2 times 63 times 40, and we'll close that. Now that won't be our answer. We'll then have to take the inverse cosine of our answer, and we will find what A equals. So start with your parentheses, 63 raised to the second plus 40 raised to the second minus 46 raised to the second. Close the parentheses, divided by 2 times 63 times 40. Close the parenthesis and divide. We get 0.68 something, okay? Now we're not done. We do second cosine, second answer, close your parenthesis, hit enter. 46.7, so if we round up, 47 degrees. All right. That's our final answer, and we are done. Hope you guys had a great day. If you have questions, please reach out. Remember, our test is coming up on Friday, so we are getting close. Hope you guys